Okay, so we're going to talk a little bit about graphing inequalities. And so the first part is to understand is that most of graphing inequalities is almost exactly like, well, it is exactly like graphing like an equality. So we have an equality here with equal sign. Inequality would be something that's formed using one of these symbols here: less than, greater than, less than or equal to, and greater than or equal to. So you're only going to have to worry about these and graphing differently near the end when we start actually drawing the graph. And it's because of because these mean something different than that. These two symbols are actually combinations of this and this. So if you take a greater than symbol and you put it together with an equality, an equal sign, then that's what this means. So greater than or equal is this one right here. Less than or equal to, that's less than or equal to. Okay? So we're going to start off, and you can graph this any way you want. You can use a table or whatever. The easiest way, since this is in slope-intercept form, the easiest way to do it is just to use slope-intercept form. So we're going to identify the slope and identify the y-intercept. And just like you would if it was an equality, you're going to find the x term, find the x, whatever the coefficient of x is, that's going to be your slope. There it is, 3. And when we graph it, remember we want to think of it as a fraction because we're going to be moving horizontally and vertically. The numerator tells you the rise or how much to move it vertically, and the denominator tells you how much to move horizontally, and also the direction, right? Positive is up or right, depending on which one you're talking about. And the y-intercept will be your constant. If there's nothing there, then that means the constant would be 0. But in this case, we have something. So it's -2. Now remember, that's the y-intercept. So it's going to be found along the y-axis. This is a point, 0, -2. So we're going to start off by identifying these 2 points. Then you start off by plotting a couple of points. So we need the y-intercept first, just like if it was an equality. So 1, 2, 3, 4, 5. So we're going to plot that first point, 0, -2. Now the first couple of points, just like with inequality, we want to be able to know where the line goes. But the line is going to serve a little different purpose than it will on the equality. So first you plot that first point, then you use your slope to find the second point. The rise is 3, so we're going to go up 3. Right, 1, 2, 3, and over 1, and that gives us our second point. Now we have to be a little careful here because if we draw a line, a solid line through these 2 points, then every point on this line should satisfy that. Now, but if we test these points right here, we can see that's not true. So for instance, let's just take the first one, 0, -2. If you plug that in, zero goes here, right? 3 times 0 is 0. 0 minus 2 is -2. Okay, so if this was an equality, we would have y equals -2, right? Okay, which is that number right there. So if it was an equality, that would be the correct point, and it would be on the line, which it's on the line here too. But the problem is -2 is not less than -2. We have a false statement. So this really is not part of the answer. We still need it, but we don't need this line to show us what the answer is, which is what this would be telling us. We need it to divide our coordinate plane into 2 sides. It's going to be a border. So instead of drawing a solid line, I'm going to draw a dashed line. Now we can still use this now. And like I said, it's going to give us a border. So there are a lot of things that are borders. We can use fences, walls, things like rivers. The Colorado River, it forms the border between part of California and Arizona. So where that river flows, if you're on one side of the river, you're in California. If you're on the other side of the river, you're in Arizona. So that's how borders work, right? So this is our border, and instead of California and Arizona, one side will be where all the correct answers are, and the other side will be where all the wrong answers are. So we can figure that out just by picking a point. Now it won't make any sense to pick one that's on the line, but we can pick one that's off of the line. You can pick it over here or here. It can be anywhere you want, but as long as it's not on that line. So I'm going to pick one on the y-axis because that'll be a little bit easier. So I'm going to pick this one right here, 0, 4. Now this is the idea. If you were in California, for instance, but you didn't know it, the river's here, you got turned around, you got lost, maybe somebody blindfolded you and spun you around, and then they dropped you on one side of the river, and you didn't really know where you were. Well, you could find out by asking somebody, are you in California? So somebody might be standing over here, and if he says, yes, I'm in California, well, then you are, because everybody on the same side of the river is in the same state. Now, if he says, no, you're in Arizona, then to get to California, you have to go over and cross the river. So what we're going to do is we're going to find out if this point right here gives you the right answer, or if it gives you the wrong answer. If it gives you the right answer, that means every other point on the same side will also give you the right answer. If it's the wrong answer, every single point over here will give you the wrong answer. And in that case, you have to go to the other side to get to the right answers. Okay? So let's go ahead and test it. So 0, 4. We're going to take this right here, and we're going to plug it in, just like we did up here. But I'm going to go ahead, and I'm going to replace both the y and the x. And we're going to plug it in, 0, 4, and we're just going to test it. We're going to multiply everything out, and then when we get done, we're going to have a statement. And the statement will either be a true statement or it will be a false statement. So 3 times 0 is 0, -2, and then we have 4. So what we have is 4 less than -2. Okay, so now once you finish calculating that, you have to ask yourself, is that true or is it false? So like if I said, if there was a test question, for instance, that said, tell me a number that is less than -2, and you answered 4, would that be a correct answer? And in this case, the answer is no, it's false. So this one right here is false. It's not true. That means every point over here on this side of a border, our border, is going to be false. Okay? Everywhere. So no matter what numbers we pick. That means we go to the other side and we pick, and then we know every point on this side will be true. We don't have to test it again, okay? Because we know that's how that border works. One side is true, one side is false. And so if this side is the true side, that would be false. We know now because we tested it, this is the false side. That means this has to be the true side. So we should be able to just shade it. And it's you don't have to shade everything, but you should shade along the line and shade back. Okay, so this shows you, and sometimes you might want to shade further, and that's how you shade it. Okay, so one side or the other, and you find out which side to shade by picking a test point. We could have used this point too as well, right? Any point. If we wanted to test that again, now that's a 5. That would be 5, 0. What happens? 0 less than 3 times 5 minus 2. 13 minus 2, 13. Now this one is true, right? 0 is less than 13. Okay, so that's how you test that. Okay. Now, if you have the only difference between graphing one like this and one where it could be equal as well, the only difference is now whatever is on the line would be true. And so instead of a dotted line, or dashed line, I should say, so this is going to be dashed, this will be solid. Okay, so something like this, let's say we use the same exact numbers. If we plug this in, let's say 0, 2, right? So y is greater than or equal to 3 times 0 minus 2. If we were trying to find out the y value by plugging in the 0, we should get a 2, just like we got up here, right? Oops, I have this going the wrong way, I'm sorry. Okay. Okay, in this case, now if we use our table and we say y is negative 2, now our point 0, negative 2. Remember, we picked x equals 0 first, so our point 0, negative 2, this one would be true, right? So it's true. It's a true statement to say negative 2 is less than or equal to negative 2. It's not less than, but it is equal. So then that would be true. Now, since it's true, every point on this line is going to be true, and we would need a solid line instead of a dotted or dashed line. So dashed is for this. So dash is when you have that, and solid is when you have an equality.